mostly quiet. We have no solar flares, no geomagnetic storms, and no erupting filaments. But we do see a filament growing, and it's being fed by a nearby active region. On the south, the bright leading group is loosing solar plasma into the thin coronal rope. Eyes on that one for sure. Second, we also have another active region incoming on the south, and this one actually has a solid sunspot umbra. It is indeed the grouping from the turn of the month, survived all the way around to say hello to Earth again. It does appear alone, so peripheral development will likely be required before any considerable activity there. Looking at the solar wind for the third thing to watch on the sun, top left we continue into the slightly more intensified stream, but it's only brought us from anemic to normal solar wind. Bottom right, the KP index is all in the green, but we still will have to watch for that second solar wind intensification from the core portion of the coronal hole. The deepest south aspect just faced Earth yesterday, and so its solar wind peak intensification is likely at least 12 to 24 hours away, if not a bit more. And most of you know, Jupiter and Saturn almost eclipse one another from Earth's perspective tonight. It will not be visible for long after sundown, but if you don't get a chance to see it, just know that it's going to be you and every other planet watcher frustrated by the sun over the next 2 months. Not only do Jupiter and Saturn take a while to break their conjunction, but Mercury just conjoined the sun. Venus is on approach to conjunction, and were it not for that pesky atmosphere, it would appear that the gods are meeting in Olympus. Top quake of the last day struck Japan. Luckily, this was well offshore and was minimally felt on the coastline. But the bigger story beneath our feet came up to say hello. Hawaii, Kilauea, an eruptive phase that has not breached the walls of the volcano yet, but also just kicked off overnight. More updates coming today, I'm sure. So let's do some science. Well, sort of. Title says reduced cyclone density due to anthropogenic warming. Indeed, to be more specific, the projected Earth changes work to reduce tropical cyclone genesis action. And then they turn right around and say human-caused global warming is going to intensify cyclones' wind speed and rainfall. Confused? No. Pretty sure it's not you with the problem. Folks, we've spent all year describing the details of CO2 bias, cloud and aerosol uncertainty, and the errors propagated in large model projections. This is slightly more blunt and macro scale. The good news is it wasn't terrible at everything, at least not everywhere around the world, but lots of poor performance, as usual. And of course, what you've read in peer-reviewed journals 100 times now but never once heard in the news, still not getting any better at predicting this climate thing. Sliding to the solar storm vulnerability next, and the first paper I've seen on the large-scale risk to China. Static voltage stability issues identified in this work are just one of the reasons why, if the sun really gives us a good shot, the grids are going to be utterly devastated. Now, last but not least, a distant and only faintly visible recurrent nova shall be added to the list. It's got about a 12-year cycle and appears to be triggered by enhanced mass transfer, aka accretion, accumulation of material into the atmosphere of a star. This is how a lot of astrophysics works, actually, with higher activity. You add material to fuel the galaxy's star formation or that of a molecular cloud. You accrete material onto a pulsar and begin to see a cosmic lighthouse tear through the heavens. And of course, as was the case here and with other binaries and with that star that wandered into a molecular cloud, it caused a nova. Amazingly, this may actually redefine micronova beyond what we believe the sun's maximum output event is during its 12,000-year cycle accretion event. This one at only 10 to the 29 ergs, we're talking about the power of a strong solar flare we see every 11-year sunspot cycle. Folks, that's definitely a micronova. And indeed, when the sun does cap the 12,000-year cycle, deliver the impossible isotopes, and validation of the ancient stories about the sun, it will be substantially bigger, more like 10 to the 34 ergs. Of course, that doesn't destroy planets, it's just shedding that outer skin accumulation it didn't want on it in the first place. Folks, not only is this the subject of the Cosmic Disaster playlist,